All right, welcome to our deep dive into UUIDs. I'm excited to explore this topic with you. It seems like something simple at first glance, but there's a lot more going on under the hood. We've got some great sources to help us unpack it all.
Yeah, for sure, for sure. We're going to be looking at a PyCon AU talk by Tom Eastman. And also, we've got the official UUID specification, RFC 9562, which is kind of the source of truth on all things UUID.
Perfect. And everyone's probably seen a UUID, that string of letters and numbers, but maybe not everyone knows that there are different versions and each version has its own kind of reason for existing.
Yeah, exactly. And understanding those different versions and why they exist can really help you pick the right one for your application.
Right. So before we even get into the different versions, can we just back up a second? In the RFC, they talk about this problem with creating unique identifiers. So what was it, like what problem were UUIDs originally invented to solve?
So imagine like a world without UUIDs, like you're building a distributed system and you need a way to create unique IDs across multiple machines, but you don't want to have to rely on some central authority to like assign these IDs. And that was a real challenge before UUIDs.
So it's like every computer is trying to come up with a unique house number, but like without talking to each other.
Exactly. It would be a mess.
Total chaos.
Yeah. And so UUIDs provided this way to just generate unique IDs anywhere, anytime, without needing any kind of central coordinator.
Makes sense. All right, so let's dive into the first version of UUID, version 1. And the PyCon talk gets into this. It uses a timestamp, it uses your computer's MC address, and it uses something called a clock sequence. So the timestamp, that seems, I guess, pretty straightforward. But why the MC address?
So the idea was to leverage something that was already unique to each computer, that, as part of the UUID generation process. Back then, MC addresses were seen as like this fairly reliable way to ensure uniqueness.
Makes sense. But then it's kind of interesting. They chose to use the Gregorian epoch for the timestamp, like going all the way back to 1582. Why not just use a more modern timestamp?
Yeah, that's a little bit of a historical quirk. I think, you have to remember this was being developed in a time when different systems might have had different ways of representing time. And so using a common fixed point like the Gregorian epoch just helped ensure consistency across platforms.
Ah, I see. Okay, but wouldn't that make sorting V1 UUIDs kind of a pain? Like you'd have to decode each one to figure out the timestamp, right?
Yeah, you're absolutely right. The way that the timestamp was placed in V1 UUIDs, it made sorting them a real headache. And then plus, like including the MA address, as people became more aware of data security and privacy, that started to raise some concerns, right? Like having your computer's unique identifier embedded in every UUID you generate, maybe not the best idea.
Yeah, not ideal. So V1 had some limitations, especially with the sorting and the privacy. So that kind of leads us to the version that I think most people see and use most often today.
UUID v4, yeah. Which takes a completely different approach, relying on randomness.
Yeah. And the talk mentions like this insanely low probability of a V4 UUID collision. Like even if you generated billions of them per second for decades, the odds of getting a duplicate are just astronomically low. So why is that?
Well, it's because of the sheer size of the number space that we're working with. A V4 UUID is a 128-bit number, which gives us just this massive range of possible values.
So it's like you're more likely to win the lottery like multiple times in a row than you are to generate two of the same V4 UUIDs.
Yeah, pretty much.
Wow, okay, so V4, very popular, but it seems like there was still room for improvement, especially when it came to databases.
You're catching on.
Yeah.
Yeah, the limitations of V1 and the pure randomness of V4, it led developers to start creating their own like custom UUID implementations. And a lot of these focused on time ordering as a way to improve database performance.
Okay, so what's the advantage of time ordering when you're working with databases?
Well, imagine you're storing like data about customer orders, right? And each order has a UUID. If those UUIDs are time ordered, then newer orders are going to be physically stored closer to each other on disk. And so this can really speed up queries because the database doesn't have to like jump around as much to retrieve the data.
Okay, so it's like having a well-organized library where the books are arranged by publication date. You know where to go to find the newest stuff.
Exactly. Exactly.
Okay, so it seems like these custom implementations, they were kind of paving the way for a new generation of UUIDs. So tell me, what came next?
Well, that's where UUID version 6 and 7 come in. Like they really address a lot of these limitations that we've been talking about.
Oh, new versions. I'm always excited to hear about the latest and greatest. So tell me, what makes them so special?
So version 6, it's kind of like they took the best parts of V1 and just rearranged things a little bit. It still uses a timestamp and a clock sequence, but the timestamp is placed in the correct order now, so it's actually sortable.
Ah, so no more decoding nightmares. Yeah, that's a huge win for efficiency, especially if you're dealing with like huge data sets.
Exactly, yeah. And then V7 goes even further. It ditches the Gregorian epoch timestamp altogether and just uses the familiar Unix timestamp, counting milliseconds since 1970.
Okay, so it's both like more intuitive for us humans to understand, and it's probably also more efficient for computers to work with too.
Yeah, exactly. And it gets even better with V7. They added support for sub-millisecond precision, which is pretty amazing for certain applications like high-frequency trading or scientific measurements where, like, tiny fractions of a second really matter.
Wow, so we're talking about like really granular time tracking, but wouldn't that add a lot of complexity?
It does, but the benefits outweigh the challenges for those specific use cases, for sure. And V7 also allows you to use counters within the UAD.
Wait, hold on. Counters within the UUID. I'm trying to picture this. Like, is there a tiny little odometer inside each UUID ticking away?
Well, you can think of it that way. It basically provides even finer control over the ordering. Like, let's say you're tracking a rapid sequence of events, like stock trades happening milliseconds apart. A counter in the UUID can guarantee that each trade is recorded in the exact order it occurred, even if the timestamps are like extremely close together.
Okay, so it's like a built-in sequence number for your data.
Okay, clean.
Yeah, exactly. I
Yeah.
see. Okay, that's pretty cool. So V7 sounds super powerful, but what if none of the existing versions quite fit my needs? Like, what if I need something totally custom for my specific application?
Well, for that, you have V8. You can think of it as the build your own option for UUIDs. You still adhere to the basic UUID format, but you have the freedom to define, what goes in those 128 bits.
So I could like embed application-specific data directly within the UUID itself. Interesting. But why not just like create a completely new identifier system from scratch if I'm going that custom?
Yeah, I mean, you could. But the beauty of sticking with the UED format is that you can still leverage all the existing tools and libraries that are designed for working with UEIDs. It's like building a custom car.
Yeah.
You can still take it to a regular mechanic for repairs.
Right, right. You still get the customization, but without sacrificing compatibility.
Exactly.
Okay, so V8, good balance of flexibility and standardization. Let's shift gears a little bit and talk about how UEIDs are actually used in databases. This is something that both our sources touch on.
Yeah, and I think this is where the practical value of UUIDs really shines. Using them as database keys, it has some significant advantages over traditional integer IDs, especially as your systems get more complex.
Right. And you mentioned distributed systems earlier. So how do UUIDs make things easier in those kinds of environments?
So think about what happens when you have multiple databases, spread across different servers. If you're relying on integer IDs, you need some way to make sure that those IDs remain unique across all of your databases. And that can involve some like complex synchronization mechanisms or like a central authority that's assigning IDs, which can,
Yeah, central authority could be a bottleneck.
right, a single point of failure. But with UUIDs, each database can just generate its own unique IDs without worrying about collisions. So it just makes things a lot simpler and also makes your system more robust. Plus, they can actually help eliminate certain types of bugs.
What kind of bugs are we talking about?
So let's say you're working with, multiple tables in your database and you need to like link records between them. With integer IDs, it's pretty easy to accidentally create like invalid relationships if you're not careful. And that can lead to data inconsistencies, hard to track down errors.
Ugh, those are the worst.
The worst, yeah. UUIDs can help mitigate that risk because each ID is globally unique regardless of the table or database it belongs to. So it just adds a layer of safety and robustness to your data model.
Yeah.
And as your database grows, UUIDs can also make migration smoother.
Okay, yeah. Migrations can be a real pain, especially if you hit like the dreaded integer limit and then you have to switch to a bigger ID type.
Right. With UUIDs, you have such a massive number space that you're pretty much never going to run into that limitation.
Yeah.
So it's very future-proof. And speaking of future-proofing, there's actually one really important piece of advice that the RFC emphasizes, and that is don't store your UUIDs as text in your database.
Oh, interesting. Why is that? I would have thought that storing them as text would make them more like human readable.
It does, but it's actually inefficient from a storage and performance standpoint.
Yeah.
It takes up more space,
Yeah.
than using a native UUID data type.
Yeah.
And it can also lead to some unexpected comparison results if the database isn't handling the text format correctly.
So you're saying like use the data types that are specifically designed for UUIDs, like the one that PostgreSQL provides.
Absolutely. Use the
Right.
right tool for the job, right? And it ensures efficiency and avoids potential compatibility issues down the line. And speaking of choosing the right tool, we've talked about all these different UUID versions. Let's kind of recap what we've learned about selecting the best one for your needs.
Yeah, let's break it down. We've covered a lot. So, okay, if I'm starting a new project today and I need to pick a UUID version, like, is there a clear winner?
Based on everything we've talked about and what both the RFC and the PyCon talk recommend, V7 seems like a pretty solid default choice for most new projects.
Yeah, it does sound like it really addresses a lot of the limitations of the earlier versions, and it's got some powerful features.
Exactly. It's time-ordered, uses the familiar Unix timestamp, and gives you that flexibility with sub-millisecond precision and those counters.
Right. But what about those situations where I need to create a UUID from an existing identifier, like they talked about in the PyCon talk with the financial transaction IDs?
In those cases, V5 is going to be your best bet.
Hmm.
With that name-based approach, you can take any piece of data and generate a UUID from it in a deterministic way. So the same input will always produce the same UUID.
Got it. So V5 if I need to map existing IDs to UUIDs. But what if I'm working on a smaller project where I don't necessarily need globally unique identifiers? Are UUIDs even the right choice then?
That's a good question. And the RFC actually acknowledges that for small self-contained projects, the added complexity of UUIDs might be overkill.
So in those cases, maybe just stick with a simple integer ID.
Yeah, potentially. But there's a big caveat there.
I think I know where you're going with this. Don't use 32-bit integers.
Exactly. Because even if your project starts small, using 32-bit integers for your IDs is going to come back to haunt you as your project grows. You're going to hit that integer limit eventually, and migrating to a bigger ID type is, well, it's not fun.
Yeah, that's a pain. Better to just start with a future-proof solution.
Exactly.
Okay, so lots to consider when it comes to choosing the right identifier. So we've covered a lot of ground today. What would you say is like the key takeaway you want to leave our listeners with about UUIDs?
I think the biggest takeaway is that UIDs are so much more than just random strings of characters. Like, they're a powerful tool for solving real-world problems in computing.
Right. And understanding the different versions and why they were designed the way they were, it helps you make better decisions as a developer.
Yeah, exactly. It's like having that deeper knowledge gives you a secret weapon in your developer toolkit.
Well, I think we've definitely uncovered a hidden world behind these seemingly simple identifiers. It's been a fascinating deep dive. And for those of you listening, if you want to go even deeper, we've got links to Tom Eastman's PyCon talk and the full RFC 9562 in the show notes.
Yeah, definitely check those out. You might be surprised at just how interesting UUIDs can be.
Absolutely. Until next time, keep on learning, keep on asking those questions, and keep on diving deep.